sentient being, and welcome back to Pluto. This is Punkworks. Welcome back to Punkworks. This is Pluto. Actually, I don't really know where you are, so you're wherever you are. Anyway, this is Punkworks, and we're gonna go ahead and get back to Grey Hack the game, where you're gonna be a super sleuth, stealthy hacker, miscreant, criminal type of person, if you want, or you could be like a good hacker. Are you a good witch or a bad witch? It's up to you. Anyway, we're going to finish the program that we started in the last episode, where we are creating ourselves a neat little hack tool that can get us into all sorts of systems without having to buy a new hackshop exploit every time. In the previous episode, we wrote some code, got us most of the way. Now, this program left a little bit to be desired, as we didn't quite finish it. We got, pretty far, where we're scanning addresses, and then we get to a menu that we print out, and we do stuff, and then it prints out that menu. So as you can see here, we get a list. So we want to get past that. We want to be able to select from the list and do something, right? So in order to get to that, we're going to want to improve our menu that we're printing right here. Returning to the previous menu that we made, we see that it exits after it prints the menu. We want to fix that. However, our code has gotten a bit unwieldy. And sorry for scrolling through it like that instead of giving you a chance to look at it. It is laid out in full in the previous video. If you want to go ahead and check that to get the full source code, I walk you through creating the whole thing. However, just for completeness sake, or if you just don't want to go back and do that, I will leave this on the screen for a few moments and then scroll a little bit. Scroll a little bit more. And then we're down here. So go ahead and copy that down, and then we're going to get ready for round 2. Since we're making a menu, what we want is to take this and expand upon it. We don't really want to be bothered by the rest of this code right now, since that is not our focus. We're even going to make this entire menu in a separate file, and we're going to import it using this line right here. This import code line is going to be replaced by the code in the source file or compiled importable binary at that path. This means we can forget about this for now. First, let us spruce up the menu by highlighting the index of the thing that we want to print. Now things stand out a little bit. We can actually see the numbers now. Of course, since it's a menu, we're going to want to get the user's input, right? So we add a line to do exactly that. And if they don't want to make a selection, they can quit. Here's what it looks like down here. Of course, if we make a selection right now, nothing happens. Of course, we might want to run our menu more than once. We're going to put it in a while loop. We will set running to true so that while we are running, we keep looping through the menu. At some point, if the user wishes to select Q for quit, we will simply set running equal to true. This will end the loop. There we go. And now, the menu will loop until we press Q. The next thing we're going to want to do, after we make sure that we don't want to quit, is we want to make sure that the input that we received is actually a number. If it's a letter, special character, we want to complain. And if the input is out of bounds. arguments. If it's greater than the length of the list, or it's less than 0. If it's not going to fit into one of these numbers, we need to complain. And of course, once we complain, we want to continue back to the top of the list. The object that we select from the list, remember, these are all objects, and the list that they're in is called memory. And of course, we cast our input to an integer. This input now is an index in memory that corresponds to one of these numbers. That's our selection. We're going to want to handle our selection depending on the type of object that it is. So if it's a shell, then what we're going to do is we're going to do whatever our thing we have to do with a shell. And if it's a computer, we're going to do that, and if it's a file, we're going to do that. So it's going to look like this. If type of object equals shell, then handle a shell, and we pass that function the object that we're wanting to handle. Same as if it's a computer or if it's a file. Now, of course, the obvious elephant in the room is that we don't have these functions defined yet, and that is what we need to do. We need to make a function to handle each one of these cases. Now, this is a good time to go ahead and remind us that object-oriented programming exists. So we're going to go ahead and make ourselves a menu class, which we can then, spawn a menu object whenever we get to that point, and with them further, go back and actually turn our original messy spaghetti code into object-oriented programming as well. And you'd have this as a basis to compare as you use as an exercise. This is an example to convert this over. Yes, that's right. Homework. Real quick, we're going to go ahead and change these reference calls over so that we can reference their, class. Anyway, we start with handle shell. Menu.handle shell will be our first function. It's going to take the object that we send it from memory, and it's going to process it. This process involves telling us what it's processing, converting, or rather obtaining the computer object from the shell object, and then handling it. Finally, it's going to ask, should we open the shell, such that you start terminal on that new shell object, leaving your current shell. This is useful when you need to use a GUI program such as the browser, or studentviewer.exe, or the criminal's police record, I believe, .exe, it's policerecord.exe, and others. Although, when you disconnect from one of these, it will leave a log, and also when you start one of these, if an admin is online, you're at risk of getting a trace that could lead to a game over. Generally, you might not want to do this unless you know you can clear the log, which means you're going to want to be able to get to root, which means you want the root password. And that is what the other two functions are going to attempt to do. And that is our shell function. That's going to let us handle a shell in the most basic of ways, which is to just start the terminal and then go into the machine and do things as normal. Maybe upload your tools with SCP or File Explorer, what have you. Next, we make our computer handler to handle computer objects, which, of course, is also going to be called by our shell handler. Computer handler is even simpler. All it's going to do is really just convert the object to a file and then run it through the file handler. This is because we only want the root password and maybe some mail and bank information from our target, and we're not really interested in that much else because we want this is just a very simple computer handler. We could, of course, expand upon it using the additional computer functions available and once again make an entire shell environment such that you don't have to use start terminal. But for now, we're just looking for passwords. Now that brings us to the file object handler for our little menu class there. And of course the file object is going to handle any file objects that we send it, which is going to be reference, if we get a shell or a computer, this guy's getting called. So of course we print what we're handling. We're going to make a cheeky little loop that basically, if the file that we got is not, the root folder itself, we're going to cycle backwards through the parents until we get to the root folder. Once we get to the root folder, we're going to grab all of the subfolders within it. That'll most likely, be all of these folders. And we're going to initialize a couple of variables to hold the two that we're actually interested in. Since we know where we should be looking for those folders, all we have to do is find them right there in the first layer of folders that we encounter. First, we check to see if we located the etc folder. If we did, we do some things. First, we're going to get all of the files in the etc folder. And that is because we know the passwd, the password file, is going to be in there. So we loop through all of the files in the etc folder. If the name of the file is what we're looking for, that is password, and we can read it, because it's important that we can actually read it, we are going to print what we found. Okay? If not, we're going to print that we can't read it, or that we didn't find it if we in fact did not find it. Now, if we have, of course, successfully found and read it, we're going to print what's inside of it. There are a number of things you can do with this, such as pointing that same file towards, say, the decipher program, or a decipher program of your own. However, in this situation, we're just going to print it out so that you can copy the information and paste it into another program. This is because that particular lesson is basically a separate lesson, and so either homework or we will visit it in the future. But that's, for now, an exercise for you guys. We are almost done. The final thing we have to do is handle if we find the home folder. That's where we're going to find some good stuff. Now, don't let this gigantic nested if for monster scare you. We're going to go through it line by line. If we find the home folder, we're going to do stuff. If we do not, we're going to say, oops, we didn't find it. Oh well. We're going to get all of the folders in the home folder so that we can see all of the usernames. It's going to be the usernames are going to be the names of the folders in the home folder. So that's what we got. Since guest isn't going to have mail or bank or whatever information, we're just going to skip that. Otherwise, we're going to get the subfolders in that user's directory. For every subfolder in there, we're going to look for the one that is named config. Inside of config, we are going to get all of the files that we might find in there. Amongst those, we're going to sort through all of those files, and then amongst those we're looking for mail.txt and bank.txt. Should we find those, we're going to attempt to read them. We're going to print out the path of what we're trying to read, and if it has read permissions, we're going to print the contents. Otherwise, we're going to complain that we can't read it. And that's pretty much it. So, just to kind of recap, if we get a file object, which also if we get a computer or a shell object, they're all going to cascade down to if we get a file object. We're going to get the root folder. We're going to look for the etc. in the home folder. We are then going to go through the etc. folder looking for the password file, and if we can, we're going to print the contents so that we can later copy it into another file or whatever for decipher to decipher, however we decide to handle that. Next, we're going to look in the home folder, and we're going to get all of the users in there, and for all of the users, we're going to look for their mail.txt and bank.txt files, and if we can read them, we're going to print those contents as well, likewise, so that we can send it to decipher, or we're going to complain that it's protected or we didn't find it. And you might notice that's it. That was our 3. So we're going to go through those, and once we're done with that, we're going to go back to the top of the list, and it's going to print the menu again, and we can go again. Okay, let's go ahead and compile our software. Here, let me put that last one up here so you can see. Okay, let's scroll down. There's that. That's where we stopped up there. Great. Okay, good job, good job. So that's our whole menu dealio. And finally, we're going to change this right here to make it a little better. So a little more portable, maybe. Instead of using this global memory variable that we made in our other code over here, we're going to make this a little bit more modular. So we're going to have a declared menu.memory variable, and of course that's going to just be an empty list. And we're going to change this here to that. And that. And that. That way, we are able to instantiate this when we make our object, and then it runs the menu off of those particular results. We're going to add a function to initialize our new object using the memory value from our previous program. So when this is called, the init is called, it's going to expect to be passed that list value, and so it's going to create a new object. It's going to create that new object, and it's going to immediately set this value to that memory value. See? It's then going to return that object, which then will be stored here in my menu. And since my menu, it's basically all of these, what we're going to do is run the main function, and that is simply my menu.main. And that is it. When it gets to this point, it will run this menu until it is done, and then it will exit. Pretty cool stuff, right? Let's go ahead and goodbye. Oh, I almost forgot. Since we're creating a class and we're going to be initializing an object from this class, I actually should have used self instead of the actual memory reference, because if I use menu instead of self, what's going to happen is this is actually going to change the class value and not the actual object value. So let's go ahead and change this to self so that it actually changes the value for the actual object that gets called. Go down here and do that, self instead of menu. We have another one, self, il selfo, and selfador. Another one. Make sure we get them all. Oh, and look at that, I didn't even get it on there. Okay. That should be all of them. Okay, so there. Yeah, I did. Okay, so be sure to go through all of your code and look for any of those mentions of menu and change them to self, because that's actually what you want to use when you instantiate an object. Okay, so let's go ahead and build again. And this time we should be able to get some results. There we go, there's our menu. Okay, now finally let's test it out. Let's go ahead and select 2, because what that's going to do, so we don't have a shell object, but what this 2 is going to do is it's going to first run the computer handler, which is simply going to call the file handler. So if the computer handler is working and the file handler is working, then we'll get them both in the same go. Alrighty, and it goes through, it's handling computer, calls the file, handling file, and it says it cannot read, etc. password, and it printed that twice. That's interesting. Where did I mess that part up? Oh, because it's going to do that for every file that it finds. Okay, well that's maybe room for improvement. But as you can see, we did that and we went right back to the main menu. Since my password file is not readable, obviously it was doomed to failure. So let's change that. There we go. Now it should be readable, so let's go ahead and just do it again. Oh, because it doesn't exist. Hang on. Okay, that ought to do it. Let's try now. So when it found etc. password, it said hello world. It printed the contents. If that would have been like a hash or something, different story. And you could pipe that, like I said, to decipher. Same thing if we find a file, same process. Now if we find a shell object, then we can start the terminal. So let's see if we can find one of those. And we found a shell object. Okay, so when you find a shell object, first thing it's going to do, it's going to go through the shell handler, the computer handler, and the file handler. Okay, so it found the etc. password. Let's pretend that it has a password hash here. You decipher that. You get the root password, and you say, yes, I want to start the shell. And then there you go. Now I am user Pluto. As you can see, that shell was, I think that's what it was. One of those, the shell is the user Pluto, so that's who I logged in as when I opened the shell object. And now when I exit back out, it's going to close that, but it's neither here nor there. That's how they work. So that's also why I don't usually start the terminal, but instead I have an entire shell environment that I can use to navigate the file system without actually having to open that terminal. Okay? Alright, so let's go ahead and look at that one more time. As we take a look at our program that we just made. Okay, remember this was our original one. Let me make sure that I highlight that line there so you can see when I scroll. There's a little bit more of it. And then down here is where we get this first menu, and then this is our second menu that we are doing a little bit differently. We're doing a little bit of object-oriented programming as opposed to functional programming. And of course, all of these have room for improvement. This whole file handler can be made much more efficient. But this is all just placeholders, starting points, launching pads. And hopefully this here menu thing can be modular. You can completely disregard and discard this, but still plug this menu into whatever you replace this with, simply by that. So, some ideas for you to go over. Let me stop scrolling back and forth on this, so you can take in this part. Okay, we're going to scroll down to this line. Oops, there. That's where we scrolled from. Down to the file handler. Okay, file handler. And then that's the end of our function right there. Okay, now that is it. We have successfully created a hack tool that can get you the most basic of stuff, which is the possibility of getting the root password and the possibility of getting user emails and banks. When you get their email information, you can of course use that to send the funny game email in order to get a reverse shell. And of course the bank information can be used to rob them. Okay, so the next segment is going to be, or the next video rather, is going to be on shell, my program shell, and how I've incorporated all of this stuff into my program and how it looks, so that you can see a sleeker version of the program that we just made. Okay? And of course, just so you can of course use. We didn't do that today, but we can of course do like. And attack remotely instead of a local live. And of course, the same things. And now if I were to open the shell on the router, now you can see I am a guest on the router. Pretty cool, huh? Okay. So next video, like I said, we're going to go over things like the actual process of doing all this stuff with my program shell. And then in a later video after that, I would like to go over all the different other player tools that exist, or as many as I can anyway, so that you can see the other options that you have for playing the game. Because shell is great and all, but there are just so many other options out there that I'm not going to tell you to only use mine. I'm going to tell you to use them all. Try them all out, get some inspiration, and then make your own. Alright, anyway, see you in game. If you liked this, if any of this was useful at all, please like and subscribe, because the more you guys subscribe, the more you watch, the more you like, the more likely it is that I can, continue to make these videos. You know how it works. Alright, help me out. See ya. Bye. Packworks!